Hey there guys, welcome to the video. My name is Pushpinder Gill. In this video, we're going to be talking about the elementary operation or we can also call it transformation. So we're going to be talking about the elementary operation slash transformation of a matrix. Right? So I suppose you've already watched all the previous videos on matrix. And in this video we're going to be talking how can you perform various operations or transformations on matrix which are classified as elementary operations. These are going to be very helpful in your manipulations, algebraic manipulations when it comes to matrices. So the first manipulation that you can do is you can actually interchange any two rows. You can interchange any two rows or columns, right? So what you can do is you can actually interchange any two rows or columns. Let's suppose if I have a matrix A, let's suppose the matrix A is 1, 2, 3, 4, 5, 6 and 7, 8, 9. Let's suppose this is a matrix, and we know that this is the first row, this is the second row, and this is the third row. So let's suppose if I say I'm interchanging row 1 with row 2. So this is the way you actually denote the interchange, that row 1 is actually interchanging with row 2. Then the transformed matrix will look like, so the row 1 will actually get interchanged with row 2. So you're going to get this as your new matrix. This row is actually going to interchange with this row. Similarly, you can actually interchange columns as well, and this is how you do it. And symbolically, you say Ri is interchanged with Rj, or you can say that column I is actually interchanged with column j, right? So you can actually do it only for rows and only for columns. You can't do it for row and a column. So this is the first elementary operation that you can do. The second one, it's about the multiplication of elements with any row by a non-zero number. So what you can do is you can actually multiply a whole row or a whole column with a non-zero number. So you can multiply with a non-zero number. You don't multiply with 0, you multiply with a non-zero number. So let's suppose if I say that you have a matrix that, let's suppose the matrix is 1, 2, 3, 4, 5, 6, and I say that you multiply you kind of multiply row 2 with 2 into R row 2. So what you do is you can actually multiplying the row 2 with 2, and the matrix that you're going to get, it's going to be equal to 8, 10 and 12. So you actually multiplied this whole row by 2, and this is how you denote it. So if you multiply row I with a scalar number k, so this is how you denote it. Similarly, you can do it for a column as well. So if I say that column 1 is actually multiplied by 3, then you're going to get the matrix as 3, 6 and 9, right? So this is the way to denote it. So if I say column I is actually multiplied with a scalar number k, and that is what it becomes, right? So I suppose you're understanding this point over here, guys. The next thing that you can do is, it's actually a little complex than the first two things. It's actually you can add or subtract two rows, and you can actually perform some arithmetic operations on rows, or you can operate some arithmetic operations on columns. So what is the meaning of that? So let's suppose if I have a matrix that is 1, 2, 3, 4, 5, 6. So let's suppose the matrix is 1, 2, 3, 4, 5, 6. And I say that what I'm doing is I'm doing the first row. What I'm doing here is I'm actually adding the first row. I'm adding the first row with 2 times the second row. So this is what I'm doing. On first row, what I'm doing is I'm actually adding the first row with 2 times the second row. So the matrix that I'm going to get is, this element is going to be 1 plus 2 times 4, that is 8, 2 plus 2 times 10, that is 12, 3 plus 2 times this, which is 15. So that is what my new matrix is going to be. So generally what we do is we have Ri that actually tends to become Ri plus k times Rj. So this is some other row that I'm talking about. So what you can do is you can perform this arithmetic operations on this row, in which what you have is that you can actually add some other row, and you can actually add it with some scale. You can multiply the second another row with a scalar multiple. Similarly, what you can do is you can actually do it with a column as well. So you can actually multiply some other column with some other number, and this is what you're going to get. So let's suppose if I want to talk about an example, let's suppose I have this matrix that is 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's suppose this is the matrix. And I say I'm multiplying the second column. I'm actually changing the second column as column minus 2 times the third column. So what is the result that I'm going to get? It's actually equal to, this is 4. So this is 4 into 2, 4 minus, so this is 4 minus 2 times 7. This is 5 minus 2 times 8. This is 6 minus 2 times 9. And we're changing only the second column and not changing the third column at all. So these are the 3 different arithmetic or elementary operations that you can actually perform on operations. So if I go ahead and summarize this, so the summary of these 3 operations. So the first one is that you can actually interchange the rows, and you can actually interchange the columns as well, right? So you can interchange rows and columns. The second thing that you can do is that you can actually multiply a row with a scalar number, and again you can multiply a column with a scalar number, provided that k is not equal to 0. The third thing that you can do is you can actually add or subtract a scalar multiple of another row, and same thing is actually you can do with columns. So this would be about this video, guys. Thank you very much for watching this video, and make sure that you explore perfect-scores.com, wherein you can explore a lot of exciting stuff. And this would be our Facebook page to give us your valuable like, and this would be our email address to give us your valuable feedback. So this would be about this video, guys. Thank you very much for watching. I'll see you in the next one.